Alright, let's do example 2. In this example, we're going to have two parts, part A and part B. So, for part A, we will try to evaluate the integral of dx over x squared minus 9, square root of x squared minus 9. Again, determine the denominator look like x squared minus a squared radical, which means that we're going to use x equal a secant theta, and we want theta to be between 0 included and pi over 2, or theta to be between pi and 3 pi over 2. In other words, we want it to be in the first quadrant or the third quadrant. Okay, square root of x squared minus 9 is the same thing as x squared minus 3 squared radical, which means a is equal 3, which means we're going to use x is equal 3 secant theta. So therefore dx, we take a derivative of constant times secant is that constant, which is 3. Derivative of secant is secant theta tangent theta d theta. Now we need to calculate square root of x squared minus 9, and that is 3 secant theta everything squared minus 9, and then you want square root of the whole thing, which is equal to radical of 9 secant squared theta minus 9. Now we factor the 9, we get secant squared theta minus 1, which is equal 9 secant squared minus 1 is tangent square, so tangent square of theta radical, which is equal to 3 absolute value of tangent of theta. But the tangent in the first quadrant and the third quadrant, tangent of theta is positive, and tangent of theta is positive in third quadrant. Therefore, this is equal just 3 tangent theta. Now let's evaluate the integral of dx over square root of x squared minus 9 is equal square root. Now dx is right here. This is my dx, which is 3 secant theta tangent theta d theta, and the square root of x squared minus 9 is right here, which is equal 3 tangent theta. Now simplifying tangent theta and 3, this is going to be equal integral of secant theta d theta. Integral of secant theta d theta is ln of secant theta plus tangent theta. Is one of those integrals you need to memorize, which is equal ln absolute value of secant theta plus tangent theta plus a constant. Since we first need to express the integral in terms of the original variable x, observe that we have x equal 3 secant theta, which means secant of theta is equal x over 3. Now using the triangle sides minus 90 degrees. Let's assume this is theta. Secant theta is equal x over 3, means the hypotenuse is x and the adjacent side is 3. Now let's call the opposite side c. Now from the Pythagorean theorem, we know that 3 squared plus c squared is equal x squared, which means c squared is equal x squared minus 9. So c is equal square root of x squared minus 9. This is x squared minus 9 square root. Now the integral of dx over square root of x squared minus 9 is equal ln secant theta is just x over 3 plus, and the tangent theta is x squared minus 9 square root everything over 3 plus some constant c. We can simplify the ln using the property. This is equal ln of the top. The numerator is just x plus square root of x squared minus 9 minus ln of absolute value of 3 plus c. Now we can call this another constant c1. So therefore this is equal ln of x plus square root of x squared minus 9 plus some constant c1. Now let's do example B, but we will be using example A to finish solving example. We will be using example A to finish solving example B. So let's do radical of dx, integral of dx over 9x squared plus 6x minus 8, square root of the whole thing. By looking at the integrand, notice that we do not know which trig substitution is appropriate. Therefore, we need to first complete the square under the root sign. Let me show you how to complete the square. So 9x squared plus 6x minus 8. First, we're going to be using the identity a squared plus 2ab plus b squared is equal a plus b squared. So notice that the first term can be written as 3x squared. So this is my a, 3x, plus I need 2 times a, which is 3x, times b. So the b has to be 1. 2 times 3x times 1 is 6x. Now, all I need to do to add the b squared, the b is 1. This is your a. So therefore, I need to add b squared. And if I add 1 squared, I need to subtract 1 squared. Don't forget minus 8. So far it makes sense. 3x squared is 9x squared. 2 times 3x is 6x, plus 1 minus 1 is 0, minus 8. Now this is going to be equal to, if we just complete the square for this one, this is going to be 3x plus 1 everything squared, minus 1 minus 8, which is equal to 3x plus 1 squared minus 9. Okay, now let's try to evaluate the integral. This is dx over 9x squared plus 6x minus 8, square root of the whole thing. This is equal integral of dx over 3x plus 1 squared minus 9, square root. Now if we let this substitution u equal 3x plus 1, which means du is equal 3dx, which means dx is equal du by 3, then this becomes we said dx is equal du over 3, so we need to write du over 3 over, now 3x plus 1, we said it's a u, so this is going to be u squared minus 9. Now I'm going to take 1 over 3 outside. This is going to be equal du over u squared minus 9 square root. Now from part A, we have square root of dx over x squared minus 9 square root is equal ln of x plus square root of x squared minus 9 plus some constant c1. So therefore, square root of dx over 9x squared plus 6x minus 8 radical is equal, if you look at this integral, it's exactly the same as part A. So this is equal 1 over 3. Just replace the u by x. This is going to be equal ln of u plus u squared minus 9 plus some constant c1. Now all we gotta do is replace u by 3x plus 1. It's right here. So 1 over 3 ln u is 3x plus 1 plus square root u is 3x plus 1 squared minus 9, everything plus c1. If we're going to go one more step, this is equal 1 over 3 ln of 3x plus 1 plus, remember square root of 3x plus 1 squared minus 9 is just, because we complete the square, it's just 9x squared plus 6x minus 8, everything plus c1. And we're done with this example.